Welcome to sections 1.3 and 1.4, random sampling and other effective sampling methods. We're going to do two sections and then summary video. So let's get started. By the end of this lesson, you should be able to obtain a simple random sample, describe the difference between the stratified, systematic, and cluster sampling techniques, and obtain a stratified, systematic, or cluster sample. So simple random sampling is the process of using chance to select individuals from a population. For example, we have a population of 12 individuals. Random sampling would be basically drawing numbers from a hat or using a computer to randomly generate certain numbers, however many you need from the population. So we have sample size of 12, and you might say I'm gonna randomly generate from this population using a computer, and it generated 2, 5, 8, and 10. So then I have my sample, which is 2, 5, 8, and 10. That's it. That's a simple random sampling. The key idea here is that every sample is equally likely. And the strategy that we can use is like choose random generators or random numbers, drawing from a hat, etc. Other sampling methods, we got stratified, systematic, and cluster. So let's start with the stratified sampling. Stratified sampling is obtained by separating the population into non-overlapping groups called strata. In other words, stratified sample is a simple random sample of different divisions of the population. So to illustrate this, I have a population of 12. I will look at some particular characteristic I'm interested in this case, the colors. And I want to make sure that I get a proportional number of my population from each of those colors and then split it up according to that strata. Again, in this case, the colors. And now, since I want a sample size of 4, in order to make it proportional, I can randomly choose one from blue, two from red, and one from green to keep the proportion. The key idea here is that sample needs to be chosen according to some characteristics or the strata. And the strategy that we can use is sort the population according to the characteristics, then choose a proportional number from each group. Okay, next is systematic sampling, and systematic sampling is obtained by selecting every kth individual from the population. In other words, putting your population in line and then choosing every so often. So if I have this population, I'm going to put them in line, and then I'm going to start choosing every so often. For example, if I want to choose 4, I would need to choose every third because 12 divided by 4 is 3. And to make it random, you should start at a random point between 1 and 3. So for example, I might randomly start at 2 and go every third. It gives me 2, 5, 8, and 11. So that's my sample, 2, 5, 8, and 11. So the key idea here is that population is conveniently ordered somehow. And then the strategy that we can use is to calculate the k, then choose every kth starting at the random point between 1 and k. The next sampling method is the cluster sampling. So cluster sampling is obtained by selecting all individuals within a randomly selected collection of group of individuals. In other words, from the word cluster meaning a group. So in cluster, your population has to already be grouped somehow. Maybe city blocks, egg cartons, college classes. So these are clustered somehow. So if I want a random sample of 4 on my population of 12, I would randomly select 2 clusters. Now take note of this. The clusters each have to be mixed. They have to represent the population. Cluster is only when the population is already grouped together, and you're not sorting them at all. they're already clustered, and each of the clusters really represent the whole population. So if I'm gonna have this clustered population, so each cluster here represent my population, and then I'm just gonna randomly uh, get samples from those two clusters. So the key idea here is that a population is grouped into clusters, which each represent the population. And the strategy that we can use is randomly choose an appropriate number of clusters. Another method is convenience, which is really not a good strategy because it's not random. So these are the people at the mall taking your example or going door to door, or they are individuals participating in a survey that are not chosen using random sampling. So by doing this, the sample is not a representation of the population. That's why it's not a good sampling method. The next one is the multi-stage sampling. It is used mostly for large-scale survey, which obtains sample using combination of the techniques we've mentioned: simple, stratified, systematic, and cluster. For example, suppose a farmer is interested in the health of trees in his orchard. He stratifies his orchard into 8 tree by 8 tree squares. Then he classifies each row of 8 trees as a cluster. He then randomly selects one row of trees per stratum to study. As you can see, he used a combination of the techniques we've already talked about, the stratified and cluster. So to illustrate this, let's say this is the orchard. And then what he did first is stratify this orchard. So he's going to draw 8 by 8 tree squares. So that would represent one stratum. So one square will represent one stratum, which is 8 by 8 trees. Then what he does is represent each row as a cluster. That means he has 8 clusters per stratum. So he would have 8 clusters per stratum. Now he wants to take this sample. So he will number each cluster within each stratum. So 1, 2, 3, 4, 5, 6, 7, 8. So let's assume that the top row is always row 1 and the bottom row is always row 8. Next, he will generate a random number 1 through 8 for each stratum. So let's take this first stratum right here. Let's say for this stratum, he would randomly select 5. So that means here he randomly select 5 for the first one. For the second stratum, let's say he would randomly select 1. So the first row on the second stratum, so those are the trees that he will study. So for the first stratum, he will study those trees on row 5, and on the second stratum, he will study the trees on row 1. And he would continue until he has a cluster of trees from each of the 9 strata. So he will then take those trees, then combine them together into one big sample, and that sample being called a multi-stage sample. So let's summarize these strategies. We have the simple random sample where we have our population and we just randomly choose our sample with a hat or a random generator. And then we also talked about the stratified sampling where the individuals are sorted according to some criteria. And we also talked about systematic where the individuals are already in line and we're choosing every kth position. And then we also have cluster where the individuals are mixed together and we're choosing a certain number of clusters. So that's it. Thanks for watching. Make sure to go over the whole presentation for extra examples and my notes on them. The next video summary is about bias in design experiments. See you then.